All right. Geometry 1.4 video notes, special angle pairs. So yesterday we talked about angles and we figured out how to classify angles: acute, obtuse, right, straight, how many degrees they have. We learned the angle addition postulate, which we're going to use a little bit today, but today we want to get into some special pairs. And this little graphic organizer here in the center kind of highlights all the special pairs of angles. There's 5 of them we're going to look at. So starting in the upper left, adjacent angles. Adjacent angles are 2 angles in the same plane. They have a common vertex. So these 2 angles right here share the same vertex or the same hinge. And the key part is they share a common side. So this side right here is involved in both angles. So if I kind of color code these angles, the top angle here I'll do in green, and then the bottom angle I will do in blue, but they actually share this side, this red side right here in the middle. So we would say that angle 1 and angle 2, and I'm just going to put a little 1 and 2 in there, angle 1 and angle 2 are called adjacent angles. Now, some people say adjacent angles are right next to each other, but that definition is a little bit weak because you may have a situation like this where you have 2 angles that are right next to each other. However, they do not share a common side, so these are not adjacent. So it's not as easy just to say they're next to each other, but they actually have to share a common side. All right, the next special pair of angles right below it, we use this a lot, is a linear pair. And you can probably guess because of this first word, line. It's a pair of adjacent angles who form a straight line. Or the definition gets a little bit fancy and says the non-common sides. All right, so let me kind of break this down for you. This is the common side. That's the side that is shared by both angles. The non-common sides, this side for angle 1 and this side for angle 2, these 2 blue non-common sides are opposite rays. If you remember back in the first lesson, opposite rays are 2 rays that share the same endpoint but go in opposite directions to form a straight line. So these 2 form a linear pair, and I'm going to kind of let the cat out of the bag right now and give you some special insider information, and that is that 2 angles that form a linear pair, they end up being 180 degrees. All right, that's a key fact that you have to know all the way through geometry. One of the big ideas for the entire year is that linear pairs add up to 180 degrees. And it makes sense because a full circle all the way around is 360 degrees. So halfway around would be 180. So that's kind of where we get the straight lines, are 180. All right, moving right along to special angle pair number 3, vertical angles. Vertical angles, anytime 2 lines form an X, so anytime you have a line, say here, and another line coming down here, they form what's called vertical angles. And vertical angles are the angles that are across from each other. So we have this angle right here is going to be congruent or equal to that angle right there. So let's just say for argument's sake that this angle right here is 70 degrees. That means this angle has to be 70 degrees. No matter what, they're always going to be the same. And it is also true on the sides. I'm going to put 2 arcs because this angle is a different measure. And I'll put 2 arcs over here. These 2 have to be congruent as well. Okay, no matter what. So we could use this linear pair theorem that we just learned from over here, and I could figure out how much this angle right here has to be. And since straight lines are 180, I have 70 already, so 180 take away 70 will give me 110 degrees for these 2. So now, no matter how I look at it, I have these 2 together make 180, these 2 together make 180, these 2, and these 2. And that's always going to happen anytime there's an X. All right, those are called vertical angles. All right, over here on the right, we have 2 types that are kind of related. We have complementary angles. Complementary angles are I'm going to put the word any here, any 2 angles whose measures have a sum or a total adding up to 90 degrees. Now, they do not have to be adjacent. If you notice here, these 2 angles right here, these guys they don't share a common side, they're not adjacent, but if I say they're complementary, they have to add up to 90 degrees. So I'm going to put a big equals 90 degrees out here to the side. So for instance, if this one was 60 degrees, this angle would be 30 degrees. So complementary adds up to 90. Very similar supplementary angles, same idea, except for they add up to 180 degrees. So for instance, if this angle was 160, I'm just guessing, this angle would be 20. Now, the things kids get confused is they forget which is which, complementary or supplementary. So here's a little hint that kind of helps me out. C comes before S in the alphabet, and 90 comes before 180 in the alphabet. So I kind of remember that the smaller letter goes with the smaller number, and the bigger letter goes with the bigger number. Like bigger letter, because it sounds kind of weird, but the higher letter in the alphabet. So that's how I've always been able to keep the two. If you have another way, share it with me, and maybe I'll tell the whole class about it. All right, moving on down. We get into some examples here. Just naming complements and naming special pairs. So example 1, find the complement of angle Z. So here's the vertex, angle Z, and this angle is 42.1 degrees. So remember, the complement, I have to find another angle that adds up to 90 degrees. Now I normally wouldn't write it out like this, but since it's the first time, I'm going to write it this way. Some angle plus 42.1 has to equal 90 degrees. All right, if we wanted to get really formal, we could use algebra and say x plus 42.1 equals 90. But you probably just know that you could use your calculator and you could do 90 minus 42.1. Subtract that out, that's what, 47.9. So the other angle would have to be 47.9 degrees in order to add up to 90. Now the supplement, remember, supplement, we have to get it to add up to 180. So we can kind of play the same game. What angle added to 42.1 equals 180? Well, I'm just going to do a subtraction move. I'm going to subtract, and that's going to give me, what, 137.9. 137.9. So in general, if you want a general way to look at it, to find the complement or the supplement, you're either going to go 90 minus the angle that's given, or you're going to go 180 minus the angle that you're given. All right, this will get you the complement, this will get you the supplement. Just kind of a general idea. Number 2, name the type of angle pair. Well, when you look up above at your graphic organizer, the special pair that these two guys are, I see that they share this common side. They're right next to each other and they actually share the blue side. So these two are called adjacent. Now aside from that, I don't really know anything special about them. They're not vertical angles. They don't form a straight line. I don't know how many degrees they are right now. So right now I'd just say they're adjacent angles. But down here they give me a little extra piece of info. They say the measure of angle 1 is 60 degrees. So immediately I label my picture, 60 degrees. And then it says find the measure of angle 2 if possible. Well, I really have no idea what angle 2 is. I cannot say these two angles are equal because there are no arc marks there to tell me that they're equal. They didn't tell me that the blue ray right here was a bisector. If they would have told me that was a bisector, I would know they're equal. But right now I'm going to just say it's not possible because it's not a special pair besides adjacent, and adjacent doesn't give me any numbers. Now this next one does. Type of special angle pair. Well, these two are adjacent because they share a side. However, the most important part to notice is they form a straight line. So right away, I know that the whole thing is 180 degrees. So these two angles are actually supplementary. They're going to add up to 180. So these are a linear pair because they form a straight line. And if the measure of angle 1 is 60, I now can find the other angle, because this angle has to be 180, take away 60, or 120 degrees. So now I know that the 60 plus the 120 adds up to 180, and everything does what it's supposed to do. All right, let's keep on rolling. On the back side, angle 4, kind of keeping the same idea flowing here. What special type of angle pair? Well, these two are vertical angles because I see the X. Now, one thing I want to point out right now, don't be tricked about an angle that does this. If you see a straight line and then you see another line come down and then all of a sudden just change direction a little bit, these are not vertical angles. All right, vertical angles are only created by two perfectly straight lines. This line right here that kind of came down and then took a bend, that's got an issue in it. It's not straight. So these are not vertical angles. There are going to be some diagrams later on in the course that they try to trick you a little bit with that. Wannabe vertical angles, I call them. All right, so let's label our picture. The measure of angle 1 is 115. The most important thing that kids don't do is they don't immediately go over and write it on the diagram. You have to do that. So angle 1 is 115 degrees. Find the measure of angle 2 if possible. Well, sure, it's possible because vertical angles, the opposite angles here, have to be congruent or equal. So if the top's 115, the bottom's 115. And then also, what is the measurement of the two remaining angles? I also know how much these guys are because they form, there's a linear pair going on right here. From this line all the way over to this line has that up to 180. So I should be able to find this angle right over here. I do 180, take away 115, boom, 65 degrees. And since these two are vertical angles, 65 degrees. So all I ever need is one out of the four and I can get all of them. It always works like that with vertical angles. All right, moving on down. All right, the directions, I kind of lost the directions. Let me scroll back up. Find the measure of all angles in the diagram. Perfect. All right, so I look at this diagram. First thing I see is that they tell me that I have an angle that's 60 degrees. It's always nice when they just flat out give me a number. Now, they don't give me another number explicitly, but they actually have this little red box in here, this little red box, and that means that it's a right angle. So I know that this one is 90 degrees because remember that little box like this, means 90 degrees. So let's kind of start using some facts that we know. First thing I realize here is this is a straight line. So this angle plus this angle plus this angle, all three of those angles have to add up to 180. Well, right now I have 60 plus 90. I have 150 of it. So this little sliver over here should be 180 subtract the 150 I already have. So that's 30 degrees. So I have that one. Now, if you notice, and this is where things get a little bit tricky. I'm going to erase this line here, just so my diagram doesn't get cluttered. If I focus my eyes on these two blue lines, I'll see that I have a pair of vertical angles here. I have an X. So if the top angle is 30, this bottom angle also has to be 30. And now that only leaves one angle left, and that leaves this angle right here, which there's a couple different ways I could find it. I'm just going to use the fact that this green arc right here has to be a straight line. It has to be 180 degrees. So again, I'm going to use the 180 fact, and since I already have 30 right here, 150 plus that 30 should add up to 180. Now you can always check at the very end. All the way around, if you do the full circle, they better add up to 360 degrees. And I think if I checked it, 30, 90, 60, 30, 150. If I add all those up, 12, 18, 21, 26, carry the 2, 360 degrees, it checks out for me. So sometimes you want to do that on a test just to make sure that everything you did was right and accurate. All right, moving to this diagram over here to the side. I'm actually going to blow this up a little bit because on my screen it's a little bit small. So let's just make her a little bit bigger. All right, I see some algebra in this problem, so this is going to require a little bit more work. First thing I notice in my diagram is I notice this red box. So basically that means from this line to the other line that the box touches is a right angle or 90 degrees. So that means that this green angle right here plus this blue angle right here, all right, this piece and the green piece added together, they need to add up to 90 degrees. So I'm going to just write a little algebra equation. You know, let's just call it angle 1 and angle 2 to make life easy. So the measure of angle 1 plus the measure of angle 2 needs to add up to 90 degrees because of that box. And then they tell me how much they're worth. Measure of angle 1 is 3x plus 6. The measure of angle 2 is 6x plus 3 equals 90 degrees. So all I've pretty much said is angle 1 plus angle 2 is 90. Now we just got to solve it. We got to combine some like terms. So on the left hand side of the equation, I can combine the 3x and the 6x to get 9x. I can combine the plus 6 and the plus 3 to get a plus 9. And now I'm down to a two-step equation. Remember, always isolate the x term first. So leave this term alone. Don't divide by 9 yet. Leave that alone. Minus 9 from both sides. I get 9x equals 81. Oh, this one's going to work out nice. This is the times table fact. 9 times what is 81? 9 times 9 is 81. Now, I'm not done. It didn't say find x. It said find out how much the angles are. So I'm going to take this 9 and I'm going to plug it in to find out the real measure of it. So angle 1 is 3 times 9 plus 6, or 27 plus 6. So that would be 33 degrees. Now I could right now figure out angle 2 just by subtracting 33 from 90, but I'm going to plug it in to make sure that it works. So I'm going to do 6 times 9 plus 3, which is 57. And hey, it checks out. 33 plus 57 has to be 90 degrees. Now I could also get these other three angles here based on what I have and using the special angle pairs. So since this is a straight line, I know that this right here all the way around has to be 180 degrees, and I already have 90 of it right over here. This is already 90, so the other side has got to be 90. So there's that angle. I can also come up here, I'm going to bust purple out this time. This angle and this angle are vertical angles. Because see how this X right here between the purple line and the blue line? There's this X, so this angle and this angle have to be the same. So that's 33 degrees. And then finally, I can figure out the last little piece because I know that from right here all the way around is 180. 180. And I already have 33 degrees of the 180. So if I subtract those, that'll give me 147. So I'm always trying to make lines add up to 180. I'm trying to make right angles add up to 90. That's kind of the name of the game. It's kind of like a puzzle we're just trying to put together. All right, moving on down to the last couple. Down at the bottom, this one's going to go pretty fast. So right away I look at the two angles. I see a straight line, so I know both sides of that line have to add up to 180. And they actually hook me up and they just say, hey, this is 142. So a couple things that I can do here. If it says solve for x, then I'm going to need to set up an equation. And since I know that this line from here to here has got to be 180 degrees, and I already have 142 of it on the right, I can subtract those numbers to find out that the left has to be 38 degrees. So I know that that left angle is 38 degrees, but they're telling me it's x, I think that's minus 33, x minus 33. So I need to figure out what x will make it work out to be 38. So I'm just going to add 33 to both sides. And I get an answer of 71. So if they actually just want me to find x, x is 71. Now if they want me to find all the true measures, this would be really easy. I didn't even need to do x. Once I have 142 and 38, I know this angle and this angle are vertical angles. They're formed by an x, so they have to be equal. And I also know that since this bottom angle is 142, this top angle is 142. So vertical angles kind of open the door to a lot of questions. All right, final example here. I'm going to blow this one up a little bit too, just so I can see it a little bit better. All right, let me get rid of those green dots. Sorry about that. Scroll down. All right, so last question. This one's kind of different because they actually give me an outside of an angle. Remember, there's an interior and an exterior. Well, when I focus on this blue angle right here, this big one, they give me the outside dimension, which is 245. So that's kind of nice because that's a pretty big chunk of a circle. That means that this portion of the circle has to add up to 360. So 360 minus 245 means that this red portion here has the total up to 115. So now I have 245 of blue, 115 of the red, and that comes out to be a full 360. Now that 115 in the red is going to help me out big time because they tell me this angle is 32 degrees. So this one right here needs to add up to 115. So I kind of play the same game. 115 is the total minus the angle that they give me, which is 32. And I do a little bit of quick subtraction here. And I get 83 degrees. So I know this angle right here is 83 degrees. Now they want me to figure out what x is. So I say the angle is 83 degrees. I know that for sure. They're telling me it's x minus 39. So I need to figure out what x will make it work out. So this is a one-step equation. Add 39, cancel, x equals 121. So realize none of the angles in the equation or in the diagram are 121, but x's. A lot of times you're wanting to find the x value that'll make the picture true according to the rules that we've been learning so far. All right, this wraps up our lesson on special angle pairs. I'm a little bit over. I wanted to keep it under 20 minutes, but just a tad over 20 minutes. See you tomorrow.